Hello, sir.
Yeah, hi Joshita, kindly wait for 1 minute.
Oh, okay.
Yeah.
Hi, good evening.
Hello, ma'am.
Yeah, hello. What's your name? Jashita.
Yes, ma'am.
Okay. Hi, Jashita. How are you, Jashita?
I'm doing good, ma'am. What about you?
Yeah, I'm good too. I'm good. Can you turn on your camera, please?
Yes, sure.
Okay, so we'll be doing linear programming today as you asked for. Let me share my screen on. So, how many chapters are done in school? How was grade 12 going on?
Uh, we have done 4 chapters in maths,
Hmm. Linear
and
programming has been done already, or is it
yeah,
new now?
it's done. It's done.
Okay, okay. So, what are the other chapters that you completed?
We have completed matrices and determinants and
Okay,
uh, inverse trigonometric functions and relations and
okay,
functions.
okay, got it. Okay, so let's start with linear programming now. So,
Mm.
what is a linear equation? What do you understand by the term linear?
It's like something single.
Okay, so let me write an equation. You tell me whether it is a linear equation or not.
Okay.
For example, x squared plus 2x equals 0. Is it a linear equation?
Yes.
Okay, so the answer to this is no. So when can we call an equation a linear equation is the degree of the equation should be 1. So let's first see what is the degree of the equation. So the general form of any linear equation will be of this form ax plus b equals 0. Okay, if I have to talk about single variable, then ax plus b equals 0. This is the general form. See, x is the variable here. What is the power of x here? It is 1. So if the highest power of the variable is 1, then only I can call it as a linear equation. Okay, now look at the example that I have given already. It is x squared plus 2x. You have x here as well as here. What is the highest power? You have 2 here and 1 here. What is the highest power here?
2.
2. So is it a linear equation now? No,
No.
right? Because the highest power is not 1. So it is not a linear equation. We call that as a quadratic equation. Okay, if degree is 2, I mean the highest power of the variable, we call that as the degree. So if the degree is 2, we call that as quadratic. Coming to this, it is called as a linear equation. So now in this topic, like you must have studied so much regarding this linear equations and how to solve them already. Now coming to linear programming, so what we are going to discuss here is, it is completely an application oriented topic. Say for example, let's say I'm running a factory. So what will be my main aim there when I run a factory or when I do a business? It is to maximize the profit, right? I have to maximize my profit. So I'll be dealing with these kind of problems, these kind of situations will be given. I'll be converting them into a mathematical model, a mathematical problem using linear equations and linear inequalities, and we will see how to maximize the profit using a method called graphical method. Okay, this is the idea of this topic. So what we'll be doing here, we'll be formulating we'll do a mathematical formulation of a given situation, and then we will solve for the feasible solution using the graphical method. This is going to be the main idea. Okay, so for that, we need to know how to graph a linear equation in two variables. Okay, let's first discuss that. For example, let's take 2x plus 3y equals 6. So this is a linear equation in two variables. I have two variables x and y here. Any idea how to plot them, how to graph it? This
We
coordinate
make the solution table and then we get the
Yes,
points.
exactly. Exactly. So what is the simplest way here is, you can just have 2 points alone. Okay, minimum 2 points are sufficient to draw the line. So this is basically a straight line. All the linear equations, the graphical format, no, it was going to be a straight line. So here, when I put x as 0, okay, in this linear equation, if I put x as 0, what will I get? 2 into 0 plus 3y equals 6. So I get 3y equals 6. So what will be the value of y then?
2.
2. So 0, comma 2 is 1 point. And if I put y as 0, I can easily find the x coordinate. So if I put y as 0, I get 2x plus 3 into 0 is equal to 6. So I get 2x is equal to 6. So x is equal to 3. So I have the two coordinate pairs, which is 0, comma 2 and 3, comma 0. So 0, 2 will be here and 3, 0 will be here. So if I join this is my straight line. So this line equation is 2x plus 3y equals 6. So this is how I plot the graph. Yes, plot this linear equation. So we need this idea when we solve the linear programming problem. Okay, is this clear?
Yes, ma'am.
Okay, so now the mathematical formulation of any linear programming problem will be like this. In short, I can call the linear programming problem as LPP. So the mathematical formulation will be, first we will have the objective function. Objective function is basically, like I told you an example of running a factory, right? There our objective is to maximize the profit. So it is basically maximize, or sometimes we have to minimize the labor cost. Yes, so that in those kind of situations, our objective function will be minimized. So we will have an objective function, maximize or minimize, z equals, here we are dealing with only two variables. So you will have something like ax1 plus bx2. Or let's take ax plus by, or x, let's take x and y better. Let's have two variables, ax and by. So this is our objective function. We will be maximizing this objective function finally. This is our final aim. We will have some constraints, okay, subject to some constraints, or I can also call them as conditions. So there will be some conditions, right? So let's say again, for running a factory, there like per day, for 5 hours the laborers will be working. So for one labor the charge is this. So there may be so many conditions when we run a business, right? So according, subject to those conditions, we will be maximizing the profit, isn't it? So we will have some linear inequalities as constraints here, like a1 x plus b1 y less than or equal to some constant c1, and a2 x plus b2 y less than or equal to c2. So these are your constraints. Sometimes you may have two constraints like this, or sometimes you will be given with three linear inequalities. And this x and y will always be greater than or equal to 0. This is called as the non-negativity constraint. Okay, so basically a linear programming problem will have three parts. One is the objective function. Okay, this is the first part. And then we will have the constraints. And then the third one is the non-negativity constraints. Altogether, this is your linear programming problem. Okay. So you will have just only two types of questions in this. One is you will have to formulate the LPP. Okay, they will be given. We will be given with a situation. We have to formulate the LPP. The other way is we will have to solve the given LPP graphically. Okay, let's see how to solve the LPP graphically now. So, is there any doubt so far? If you have any doubt till this, you can ask me.
No, mom, you can go continue.
Okay. So we'll just see one quick question on how to find get the graphical solution. One second. So this is our question. Maximize 4x plus y subject to the constraints x plus y less than or equal to 50 and 3x plus y less than or equal to 90 and x comma y is greater than or equal to 0. So which is the objective function here?
Z equals to 4x plus y.
Yes, and we have two constraints here. So the first step is you have to consider those two constraints as equations. Okay, you have to replace those less than or equal to by equal sign. Just write them as x plus y equals 50 and 3x plus y equals 90. Now, can you tell me the 2 points that are needed to plot the first line? I need to draw the coordinate plane and plot these two lines now. So what about x plus y equals 50? How do I plot that now?
We make a solution table for both of them.
Yes, do the first one alone. Can you form the solution table for the first line?
Sure. It's 0, 50 and 50, 0.
Yes, let's make it 50 here. And this is 50. So this is 50, 0 and this is 0, 50. Come on, draw the solution table for the second one also.
Uh, 0, 90, 30, 0.
Okay, if we take this as 90, so this is 0, 90 and 30, 0 is here. Okay. So this is my second line. So now these are the lines, but according to the question, we have less than or equal to, right? So we have to shade the region now. Let's see which region has to be shaded. So for that, see, when I draw a line here in this coordinate plane, see, when I draw any line, the entire region is basically divided into two parts, right? So this is one region and this is the other region is basically divided into two parts. When it is less than or equal to 0, I'll be taking this region. When it is greater than or equal to 0, I'll be taking this region. So how do I conclude that? The hint is the origin. Okay, origin is denoted by 0, 0, right? So if I take the first equation, x plus y less than or equal to 50, if I replace x and y by 0, 0, what will happen? 0 plus 0 is less than or equal to 50. Is this a valid statement? Is 0 less than 50? Is that true or false? Yes, that is true. So if this is a valid one, then you have to shade the region where the origin lies. Okay, you have to shade the region where the origin lies. So for the first line, this will be my region solution. What about the second one? Which side should I shade?
It's towards the origin.
Yes, towards the origin again. So now the intersection of these two shaded regions is going to be my feasible region. So look at the intersection, see this part. Okay, starting from this here and this one. Okay, this region, which is the intersection of these two inequalities, this is called as the feasible region. So we will be having our solution in this feasible region only. Clear so far?
Yes, ma'am.
So after marking this, we will be locating the corner points of this quadrilateral formed. So this is one corner point, this is one origin in this 30, 0, and then we have another point here. So the other 3 points, let me name them as A, B, C, and O. O is clearly origin, we know the coordinates. The origin, C coordinates are clearly known, and A is also 0, 50. What about B? How can we find the coordinates of B now? Any idea?
It's the intersection of A and like some other point. So we solve those two equations and we get the point.
Yes. Exactly. So it is basically the intersection of the two lines. Yes. What are the two line equations? It's x plus y equals 50 and 3x plus y equals 90. X plus y equals 50 and 3x plus y equals 90. So I can very well use the elimination method or substitution method, whatever known, and solve for x and y. So I'm using the elimination method. I'm just subtracting both the equations. So I get minus 2x equals minus 40. So x is equal to 20. Minus 40 by minus 2 is 20. And when I put this in any one of these equations, I get 50 minus 20, which is equal to 30. So 20 comma 30 is this point B. Now, these are the corner points. Now I'll have to form the final table and see which is the maximum value. So the question here is to maximize the subjective function, right? So these 4 points, the coordinates like O, A, B, C, I have to plug in those values of x and y in this function and see which is the maximum one. Okay, if you do that, you will be getting that at point B only, you'll be getting the maximum value. Okay, z equals 4 times 20 plus 30, which is 80 plus 30. 110. So this is the maximum value of this function and the maximum value occurs at the point B. So this is how we graphically solve this LPP.
Okay.
Okay, so yeah. So you can, I'm done for the demo. So if you have any doubt, you can ask me now. Apart
No
from
doubt.
this, like what other difficulty do you have in LPP? Do you face difficulty in formulating the problem?
We have done this chapter in the school, but where I faced difficulty was when they gave 3 lines, like
Hmm.
three constraints and
Constraints. Hmm.
yeah.
Okay, okay, got
Like
it.
like I had doubt way to shade the way which is the feasible region and not which is non-feasible region. Now it's clear.
Mm. Okay, this origin is a hint for any line, for any inequality. This origin is going to give you the hint. And one more thing, when you have 3 lines, you have to graph it very clearly. Okay, the picture should be so clear such that, like looking at itself, you should be able to find the intersection. In such a way, your graph should be. Then only it will be easy for you when you have 3 inequalities. Okay.
Okay. Good.
And you should, whenever you draw this line, okay, whenever you draw this line, adjacent to that, you write the line equation also. If this is x plus y equals, this is x plus y equals 50, write that immediately near that line. This is 3x plus y equals 90. Write that immediately so that you will not get confusion with the intersection points. Here it is very clear because you have only 2 lines. But when it is 3 lines, you may get confused like which 2 lines are getting intersected. So immediately write the line equations nearby so that it will be easy for you to get the intersection point. Okay?
Okay.
Okay then. Okay then. Yeah, then I'm done with this. Yes, sir.
Jashita, do you have a parent around, father or mother? So if they have any questions, they can ask to ma'am directly.
They are not around, sir.
Oh, okay, no issues. So I think we can wrap up. Thank you.
Okay, sir. Yeah, then bye,
Okay.
Jashpita. Bye,
Yeah.
sir. Thank you.